Hello. Hello, this is TCPM. My name is Michael Tuxen. I'm one of the co-chairs. Yoshi is remote. We have a pretty packed agenda, so that's why I'm starting on time. This is the note. Well, we're in the middle of the week, so you should have read that. It applies to our work. As you all know, the session is being recorded. Thank you to Stuart Cheshire for taking notes. We have a JavaScript, Yoshi is doing that. And the generic hint, if you are submitting a draft where you think this working group might be interested in, put TCPM in its name, please. This is the agenda, changed a couple of minutes ago. So we are sort of overbooked, I would say, but we try to finish on time. So I apologize already for the presentations that you might need to be a bit shorter than planned. This is the current state. Green of our current working group documents. Green means that it's in the, well, it has left the working group, which doesn't mean that the work has been done completely. We will figure out soon. So accurate ECN is in auth 48. PRR is also in the RFC editor queue in the edit state. We have TCP Ghost X. The work is pretty stable. We don't have a presentation on that. We are still working on some input to them for an API thing. We have TCP EDO. We have the egg rate request. And, oh, sorry, what I said to Ghost X applies to the egg rate request. That is pretty stable. And we are working on an API stuff there. And we have generalized ECN. So the plan is to get the Ghost X stuff to working group next call, working group last call next. Document shepherd will be Yoshi. And after that, we will run the generalized ECN through the working group last call, and I'll be the document shepherd. After that, we work on the egg rate request. We should have the agenda here. So we will have 2 presentations about accurate ECN, which is in auth 48. But there has been it came up the discussion on 2 areas based on testing and based on review of the authors. And we will see 2 presentations suggesting modifications. Since this is an auth 48, we want to get some feedback from the working group and then pass it over to the responsible AD for dealing with that. After that, we will have a presentation on diagnostic payload for reset, extensible timestamps, extended options, which are 3 proposals to work on. And the last one is right now more for information about TCP SCOAN. Comments on that? If that's not the case, then I would say, Stuart, I'll put up your slides. Wait a minute, I need to, now you should have control.
All right, we have a short meeting, so I'll make this quick. I think you'll know if you've seen my comments on the mailing list, I've been hugely supportive of Accurate ECN, and I'm glad it got done. There is some language there about heuristics to detect broken peers that are setting the ACE field to 0 incorrectly, or it's not clear. If you read that section, the language is kind of woolly. Clearly, the working group had some doubts about it, and there is language there about the heuristic might give false positives. And in the last couple of weeks, Kunter Schepper and his other colleagues at Nokia have been doing some testing, hoping to get really good low round trip times, and they got disappointing results. And we looked at packet traces, and accurate ECN was being disabled. And Michael asked me to take a look at the draft and make a recommendation. So I'm here giving the information for the working group to make a decision. I highlighted some text from this section. It says the sender may check the value. It says what it ought to do. It's advised. This is very weak language. This wasn't even a capital may originally, but it got changed late in the process. The next paragraph says this advice is not stated normatively, even though it is, so that's inconsistent. But having given this may advice, it's then immediately backpedaling and saying it might not be the right strategy. And then it ends by saying, because reordering can happen and is legitimate, this might cause the host to unnecessarily disable ECN. And this is a big problem. We've worked so hard to give users consistent low latency, and now we have this thing where sometimes it just doesn't work randomly for no reason. And it ends by saying implementations may skip this test. So in summary, having discussed this with several people this week, we look at this whole section and we think, this is probably bad advice and it's harmful. We don't plan to do it in macOS or iOS or Linux. So if in reality all the people in the know are not doing this, we are not serving the broad community by having advice in the RFC that actually, if you're privy to the conversations, you know you shouldn't be doing. So that's what is up for discussion here. Miria has a couple of other things that she's discussed with Bob that equally seem ill-advised. The reason we're presenting this is very late in the process, and we definitely do not want to be circumventing the consensus of the working group. We want to make sure that everybody agrees. This is in the spirit of what we want to be writing in an RFC, and I'm really just an observer on the sidelines here. I believe that the IETF makes really, really high quality documents, and that's what we want to do here. We want this document to be the best we can, and that's why we have this process that we don't just say, oh, it's too late, publish it anyway. So why don't you come up here, Miria, and you can talk about the other two bits of text.
Thank you. Maybe two comments from my side. Two comments from my side. One is I talked to Richard Scheffenegger, author, co-author. He's fine with that proposal. Second, he has implemented this in FreeBSD. This heuristic is not implemented in FreeBSD, so he chose not to implement this. Are there any objections against removing this section?
Yeah, I can maybe add that Chayu is bringing this into the Linux kernel at the moment, and I think he also will remove that part, or not even bring it in. And I can confirm that Bob was also looking at this part and was concerned about the normative language. So.
Okay, thank you. Then we change the subject to another change. Give me a minute. Can I stop this?
Yes, you can hop to the next slide. I can hop to the next slide. So there is another really late change regarding the security considerations that came actually in through the AD review. Christian provided a review for, I think, the security directorate, and so he was bringing up kind of a new attack regarding when you use tunnels or VPNs. And then there was some new text added to the security considerations describing the attack and also giving information to, like, if somebody is really, really worried about their security, they should disable accurate ECN. However, this is not a new attack. It's actually an attack that can also be used on ECN and even with drop. So we were questioning why this is here, but we kind of agreed that we might want to still describe it, but like the recommendation seems to be a little bit unclear because we are not sure about the additional risk here. So this is the attack. You have multiple clients using some kind of whatever Tor-like network to be anonymous, and an attacker can see both sides and can actually tamper with the traffic. And by causing a congestion reaction on one side and then observing and then like seeing that only one of these two flows, only client B, for example, is adapting its congestion window, you can then detect which of the two server flows belong to client A or B. So that you can do that with loss, with ECN, and with accurate ECN, you get a slightly different reaction to congestion, and therefore maybe it's less visible or whatever, and therefore you can hide better as an attacker, but maybe it's also a harder attack, so whatever. This is the text that we have currently. The text is really unclear. It doesn't even really describe this attack. I think there were a couple of things mixed up. And then this is a critical part. The second paragraph kind of gives a recommendation that there might be here a problem, which is not clear. So what we're proposing is to still, after some discussion with Christian, that we still describe the attack using a few different words, but do not provide any recommendations because we cannot really assess the additional risk of accurate ECN.
Anyone having opinions on these? I mean, objections against this proposed text? That doesn't seem to be the case. So does the responsible AD has what he needs?
So Gori Fairhurst as responsible AD. I noted that there was concerns in the author's 48, so the document's currently held in author's 48. I could take input from the chairs and the editors, and we'll consult with the RFC editor and make the right thing happen. So currently, the action relies on me to make a decision about how to handle this, and I'll get back to the working group. But I'd rather see a document published that is correct and reflects the real implementation than one which we wrote and then we realize is wrong. So currently we'll hold it, and I will get back to the mailing list very shortly and tell you what to do.
Thank you, Gori, for the cooperation. Okay, thanks for that. A bit delayed. We start with the first presentation, which is on diagnostic data on reset segments. Wait a minute, I need to click.
Hi, can you hear me?
Yes, we do.
Good. Okay, shall we begin right now? Okay. Hi, everyone. Yeah. Go ahead, please. Okay. Okay. Hi, everyone. I'm Jason. I'm going to talk about the feedbacks that we received from last time in Bangkok. Before I get into those details, I would like to quickly recap a little bit about the content of this draft. This draft describes a situation where the client sends the RSD packet to the other side, and the other side has not any clue about what is going on. So we need to insert a specific reset reason into this packet so that we can clearly know what the reason causes this reset action. So there are some primary feedbacks that I only listed one of them in these slides. One is extensive experiment that we've done in production. I will talk about the other two later. Okay. This could you move to the next slide? Yeah, good. Uh, this slide is about the current experiment status. I wrote a patch that was attached at the end of the draft as appendix. It targeted Linux kernel 6.16. This patch is used to verify if there are any middle boxes in between two servers, and if any exceptional actions can occur in between two servers. So here we are. The whole experiment has been conducted and verified at Tencent. Tencent is a hyperscaler. Over 6 months, I listed 5 big components here. Good news is we have 2 important scenarios. One is L4 gateway and L7 gateways that serves so many services internally and externally. And I also tried this test on the IONet, which is a virtual device that connects between the guest and the host. I also tried some modern NICs. They are the i40E and iXGB. i40 and iXGB are the products from Intel, and I also tried the most popular one is the Menos 5. I didn't try this patch on the older kernels because usually when we propose a new feature, we need to apply it to the latest kernel. So at that time, the 6.16 is the latest was the latest kernel. I also tried the different distros. Actually, those different distros have nothing to do with this experiment because I don't see any reason why it can cause any side effect. But I did it. The most significant part is I tried some longer paths. For example, from China to Singapore, where the RTT exceeds 30 milliseconds, and I also tried a much longer path that is from China to Germany, where the RTT is more than 20 milliseconds. Yeah. Can we? Yeah. I drew a simple picture that illustrates how the simple test can be performed. When the client side tries to send the RSD packet with the payload to the other side, we need to run the TCP dump on both sides to see, for example, on the client side, if this packet can be successfully sent out to the wire, and we need to also deploy this TCP dump on the server side to see if this particular packet can be correctly received. If we can see this packet, that means 2 things. One is that there are some middle box. There are no middle box in between them. Stop receiving or sending this packet or intercepting this packet, and it also means the driver we use on the server side does not intercept this packet. After validating this packet, we need to let this SKB go up to the upper layer. That is the TCP layer. In Linux kernel, we don't have any existing or mature tool to help us understand or observe the behavior of the TCP stack, but I had recommended using two approaches if you are interested in. One is writing a kernel module, or the other is using BPF. That is a much more modern way to extract some information from the packet or from the socket. Yeah, please move to the next slide. Yeah. I stumbled on this commit in the GitHub. In 2000, TCP dump already reserved the RST payload feature as above, which adheres to the standard RFC. And when this commit takes effect, it will generate a strange string at the end of the first line, as we can see this line in the next slide. Yes, yes, yeah. This string starts with RST plus and something like that. It looks it looks very strange, but when you are seeing this, it normally means the TCP dump allows this packet through, and we need to take a deeper look into the data area of the packet to see if the specific reason uh, can be displayed to the console. I have to mention that I've done one part of this draft in the Linux kernel 1 or 2 years ago. So I asked the TCP stack to generate some specific code when I was doing the experiment. If the receive side that receives the RST packet can show or display this specific reason, that means everything is good. So please move to the next slide. Okay. This is about the kernel implementation. I would not walk you through all the details. Unless someone proposes further question about this, I will revisit a little bit. I will quickly go through some points. As to the implementation, the Linux kernel divided the reset logic into two parts. One is active, the other is the passive. So I implement this patch to apply in either of the situations. And okay, so I think I'm done with this primary feedback, and I want to talk about the feedback that we received from Michael. Michael once asked, how do we deal with the application, or how do we deal with the specific reason in the application? But actually, what I've done in the Linux kernel is relying on some tracing mechanism to help us display those specific reasons to the console. So I didn't put those specific reason to the I don't know how to say. Okay. I didn't allow such a behavior happen because I didn't find a good approach to let the application receive this specific reason. But actually, I can do this, but I don't think it's a very efficient way. I think we can talk about this if someone are interested in. It's not the Linux kernel conference, so I'm done with the presentation. Thank you, everyone. Any questions?
Are there any questions or comments?
Hey, hi, this is Lars Eggert, Mozilla. So in January, I posted some email on the list about 2 points. One was the choice to use CBOR, which is sort of pretty unusual for TCP. And the answer was that you'll revisit it if it gets adopted. And I guess we haven't adopted it yet, so it hasn't been revisited, but I still want to say that that is, in my book, a pretty severe dependency to pull in, since nothing in TCP relies on any data encoding other than like a TLV format that we use for options. The second point was that I asked whether you had done any kind of analysis or experimentation with if something breaks on the internet, if you did that a lot, right? And I might have missed it, but I wonder if you could say if you had done this experimentation. I mean, it's great to see that there's implementations and sort of individual testing and that there's TCP dump support, but that's not the same as showing that it doesn't break things.
Let me answer the second question first. I've done this. I just drew a picture that illustrates how I did in a simple test. That doesn't not mean how this is how I did in production. I deployed this feature in production among hundreds of machines to see if there are any exceptional behavior happened. So the good news is everything is good, and we don't see any exceptional behavior just because of using this feature.
Okay, could you say a bit more about where these machines were and what kind of testing they were doing? Because I'm asking this because I'm uncomfortable with the working group talking about adoption for something that we don't really know whether it has any downsides in deployment. And it is on the proponents of the technology to convince the working group that they don't exist. That's why I'm asking.
Yeah, I fully understand what you mean here. I didn't do any special tests of this feature because I just let the application or let the service run normally, and we will monitor the whole system, and we deploy some BPF tool to see if any exceptions can.
You've shown that an implementation that does this and runs over a path that forwards those packets correctly works, right? That is great. That's sort of the necessary step to show that this actually, it functions as intended. But the thing is, if you're sending a lot of these resets with payload data over the internet, does anything other than your end systems break? That is the question.
I didn't see any strange thing happens, actually.
Did you look?
Sure.
How?
We have a very mature platform that monitors everything, I think. Yeah, because that's the job of that's my job, right? I'm working at the kernel networking team, so
I understand, but I'm assuming your monitoring platform monitors your end systems. But I'm asking about the network in between those end systems, the internet. Is breaking anything on the internet?
I didn't I didn't receive any reports about this type of situation. I have to mention here that if we deploy a new feature, I will ask my team and the network team to monitor the whole paths to see if any exceptions can occur. So we are very conscious about this feature because if anything happened in production, it will cause the terrible consequences, and we can't afford it. So this is how I've done the excessive experiment.
So we have only limited point of time, but I want to stress 2 points. As an individual, I don't like this CBOR stuff there, because it would be the only place in the code where we use this. And I don't like 1,000 bytes of payload there. So I would be, as an individual, I would be happy in 4 bytes INR registered, first come, first serve kind of stuff, but not 1,000 bytes.
I remember that. I remember that. Yeah. I believe we are open to the encoding part, and we will update it to reflect the working group consensus. Sure.
So your question, you wanted to ask about working group adoption. Is it possible that you provide the working group with some measurement data to show that it is not critical, or it has almost no impact in enabling this feature? Before we do that?
You expect me to find a way to print out some data to prove its function? I don't know. I'm not sure about that. Sometimes we develop a new feature. We just need, what we need to do is check those applications, and so what would you recommend? What kind of data would you want me to provide?
Well, I would say we take this off to the mailing list to discuss what kind of feedback we use, what kind of measurement we use to progress this, because we are running out of time.
Oh, okay. We will go into more details through mailing list. Thank you.
Okay, thank you. So ETS is the next thing. Let me, oh, wait a minute. Kevin, you should be able to control the slides. Yes, we do see them.
Yeah, I should be able to control the slides. Hi, everyone. My name is Kevin from Google. And I'll talk about the ETS option here. So this is an update for the ETS option. So we proposed this option, TCP option. Our long-term goal is to subsume the existing RFC 7327 timestamp option. And in this new proposed option, we use microsecond to be the unit. And we allowed both ends to exchange their packet ACK delay. And we use this information to calculate the network RTT measurements. And in the draft, we have text to say, to recommend to use NIC hardware timestamp for a better RTT measurement when using this ETS option. And the updates, the difference from revision 0 is that we removed the maximum ACK delay exchange in the SYN and SYN ACK. And the motivation is, first, we need to save some space in the SYN and SYN ACK header, because someone in the next session will talk more details about this for the space in the TCP options. And the second reason is we now have some other methods that can limit the mean RTO value. And this makes it less critical to exchange this information in the SYN and SYN ACK. We also renamed the ECR delay by ACK delay so that we can make the definition more clear, and it also simplifies the network RTT calculation. And we also add the clear text in the draft to recommend the hardware next timestamp. So this is the updates. And the problems we try to solve in the existing timestamp option is basically 3 points. So there are delays in the end host can intentionally delay ACK, and that ACK is included in the existing RTT measurement. And the host side delay, for example, like when the CPU is in C state power saving, and you wakes up, this waking up delay will be included in the RTT measurement, which adds a lot of noise in the RTT, and also the clock unit granularity is too coarse in the existing timestamp option, which in the existing timestamp option, I don't think the text specified unit, but it can be anywhere from 1 microsecond to 1 second. But I think most of the implementations nowadays use 1 millisecond, and that is too coarse for the data center networks. So here's the proposed wire format for this option. So it has, so first is an experimental option. So it has experimental ID, and it has same TS val and TS ECR, and the definition is exactly the same as the existing timestamp option, but the unit is 1 microsecond. And it also has a field for ACK delay. I will talk more details later. So it has 2 bits for the unit of the ACK delay, and it also has 1 reserve bit for future modifications. To negotiate this option, we require that both client side and server side to add this option, and the server side can. So for backward compatibility, the client side can include both the old existing timestamp option and this new ETS in the SYN packet header, and the server side can choose either one to respond. So, so if the server TCP support this ETS proposal, then it can respond the ETS option in the header, so they can negotiate to use this ETS option. And the way we calculate network RTT is, I'll use an example in the next slides, but in these slides here, I want to say that is in the implementation, we will introduce a new TCP internal called TS recent clock. It is the time that TS recent has been updated. Is the time TS recent when the TS time was updated. And with that, the network RTT basically can be calculated as the ACK packet arrival time minus TS ECR and minus the ACK delay in this option. So in these slides, I'm showing a somewhat complex example here. So the sender sends 1 packet, but it was intentionally delayed by the client. And there's another packet, it is also delayed. And then finally the client the other side want to send back an ACK. So in this ACK packet, it is ambiguous that which ACK delay should be defined here. So in order to make a balance between the implementation complexity and the accuracy, we choose to define the ACK delay to be the green bar, the length of the green bar shown in this picture. And the other side can use the length of the blue bar minus green bar to calculate the network RTT. So here in this example, the RTT is the send time of the traverse time of P1 plus the traverse time of the ACK packet. This is the last slide. The potential usage for this option, for this ETS option. So first we want, the major usage is for measuring network RTT so that we can use it in CC algorithm. We can use the delay as a signal and design some delay-based CC algorithm. There's a SIGCOMM paper published in 2020 talking about that there's a relation between the congestion and network delay, and we can use that as signal to design some CC algorithm. And we can also use this option to calculate more accurate rate because we're now using more accurate RTT. So we can use the more accurate rate for network pacing. And in the future, we probably can also include some other signals like CSIC signals into this option for future usage. Yeah, that's my presentation. I'm open to any questions here.
Any questions? Yoshi?
Okay, I have a couple of questions as individual. So first things I'd like to discuss is pulse. So if you increase the clock, frequency, then timestamp can be wrapped easily. And so I would like to think about, is this any impact of pulse? That's my first question. And the second question is this method affects how to calculate RTO right now? So right now we are using RFC 6298 for RTO calculation. I mean, SRTT plus 4 times RTT bar. And if we use this option, do we need to change the way to calculate RTO? That's my another question.
I see. For RTO calculation, I think we don't need to change the existing algorithm. So the RTO should be used the RTT measurement, which includes this ACK delay in their calculation. So basically the existing algorithm should also work.
Okay.
And for the pause, I'm not sure I get the question.
Okay, protect against wrapped sequence number. That's a part of RFC 7323. It's how to check sequence number is wrapped around, and then by using timestamp.
I see. Yeah. I see. Because the TS-val and TS-ECR has the exact same definition, so pause is still working, but the wraparound time is reduced to 30 minutes.
Yeah.
So our thought is it's still safe to use this as pause check because that requires a wraparound requires there's no packet being transferred for like 30 minutes.
Yeah.
Also.
Yeah, 30 minutes, maybe I think there might be a discussion point. 30 minutes may, I don't know, I'm not sure, but it's maybe a little short. But I don't have a strong opinion right now, but just a comment.
Thanks.
Thank you.
Yeah, we will look into more details about this pause check in when I try to implement this in the future. Thanks.
Lars?
Lars at Mozilla. I think I heard you say that in terms of migration or coexistence, you suggested that we stick the old timestamp option and the new timestamp option into the SYNAC. Those are both pretty big, right? Which means that essentially we're not sticking anything else into that SYN. Is that really? So I don't want to open up the whole extended options thing, but it seems like burning 14-ish bytes twice is not ideal, and I wonder if you had thoughts if that can be improved somehow.
Yes, I get the question. So keep in mind this is experimental, and it has 2 bytes in it for the experiment ID. And in the long term, like maybe 10 years or 20 years later, this can subsume the existing timestamp option. So we don't need to include both timestamp option in the SYN and SYNAC.
Okay, thank you. Since we are pretty short on time, we move on to the next presentation about extended options.
Thank you. Well, Lars may not want to open the can of worms of extended options, but I do. Anyhow, a quick reminder of what we saw at the last IETF. TCP options can contain 0 to 40 bytes. This impedes implementations of some TCP features. Kevin's wasn't the one I was thinking about, but it probably falls in the bucket. This experiment extends the TCP options field so it can contain up to 1K bytes. Yes, you can put 1K bytes of options in there, but please don't. Here's a quick reminder of the status quo. We have a field in the TCP header called the data offset. It determines the data offset. It's 32-bit units of measure, and its valid values are 5 to 15. That means that the maximum size of the options field is 40 bytes. And here's what we're changing. The offset field still determines the data offset. It's still in 32-bit units. The one difference is the value 0 is now valid. When the value is 0, the options field can be as large as 1K. And here's what the options field looks like. It starts.
Can you move closer to the mic?
Sorry. The options field has an 8-bit length attribute, followed by the individual options exactly as they exist today. Now, this is all very interesting, but we have to consider backwards compatibility. Let's think first about TCP connections that use extended options during the three-way handshake, and they may use them also after the three-way handshake. If you have a backwards compatibility problem, a legacy TCP talking to a new one, the connection setup times out. The connection never enters the established state. This is annoying, but there is no solution available. As far as I can see, no amount of signaling gets you out of this problem. The second kind of backwards compatibility problem is for TCP connections that don't use extended options during the handshake. The connection enters the established state, but the first time they use an extended option, the TCP session stalls. This is annoying and avoidable with signaling. What I would like to do is address the first class of TCP connections, the ones that use it during the extended handshake, and not the second. I would like to decouple the two problems. So what's new in this draft? Well, for the purpose of this experiment, if extended options are going to be used, they must be used during the three-way handshake. If they're not used during the three-way handshake, they must not be used after that. We've put signaling beyond the scope of this experiment. Now, we've dealt with the encoding problem. We believe we will have solved the problem for that first class of connections that uses extended options during the three-way handshake, but not the second class. Yes, we may need signaling, but that's for future work. It can be decoupled and done later. So what do we need from the working group? Well, we don't need any code points. You've seen the entire solution in 2 slides. We actually know that the solution works. We have an implementation. It's worked. We can't envision how it might hurt the big internet. What we do need is an experimental RFC to encourage others to participate in the experiment. One other thing that Michael has asked me to bring to the attention of the working group, we have posted IPR on this internet draft. It's the same IPR that we post on many other drafts and many other working groups. You might want to take a look at it, but it's standard verbiage that we've posted on many other internet drafts before it. So the ask is for a call for adoption on this experimental RFC so we can get others to join the experiment. Thank you very much.
Thank you. Wes.
When you say it works, can you be clear if it only works if the other side understands it, or if it doesn't work at all if the other side doesn't understand it?
Well, if the other side doesn't understand it, it is this case.
Yeah, so
The
that
side that
doesn't-
understands
that
it
doesn't
sends
work
it.
at all. Connection never enters established
Yeah, the
state.
connection doesn't come
So
up.
what you mean is it doesn't work at all the way any other TCP option works.
Yes, the connection won't come up.
So that doesn't work.
Yeah, okay.
Additional comments?
Oh, if I could add to that, we don't see how we could add signaling to make it work.
So Gori, just as an individual, how does it interact with ECN negotiation? We've just been talking about ECN, and how does it interact with Happy Eyeballs?
I'm sorry, could you say that again?
How
ECN?
does your proposal interact with ECN negotiation using ECT, where we do retransmissions of SINs? And how does it interact with Happy Eyeballs?
Let's see, Happy Eyeballs, it certainly will interact with well, actually, it may not interact with Happy Eyeballs because Happy Eyeballs is a choice between 2 paths to the same TCP implementation. So that shouldn't make a difference. ECN negotiation, I think, is the same thing. It's a choice between 2 paths to the same oh, it's 2 different TCP.
You
In that
send the
case, there
SIN
would
and
be
you
an interaction that we
retransmit
need
the
to
SIN
study.
in a different way.
In that case, there may be an interaction that we need to study.
Okay.
Alessandro Ghedini, Cloudflare. To be honest, I don't entirely understand what you're asking here because basically, if I understand correctly, what you're saying is we are going to get an RFC to do an experiment, which, to be fair, I don't think we need an RFC to do an experiment. But even then, what you're asking is you could deploy this to like a production environment and some of your connection might break. So why would they do that? I'm not sure.
For many of the applications, you would have to configure the fact that you would need to send this additional information in the TCP. So the application would know ahead of time and both ends would have to be configured.
So it's like specific, like if you think this would be useful for your use case, then you can do the experiment.
Yes, yes.
Okay. But again, like, it's not clear that an RFC is needed to do an experiment, in my opinion. But
In one sense, you could say we've already done it. We've
right.
produced the code, it works. Or it works as well as, I'm sorry, I didn't catch your name, said that it works. It fails to set up when it's not going to work.
Right, but to go beyond the experiment, then you will also need the signaling, because as it stands,
Oh,
like,
yes,
it's
yes.
not generally,
At some point, you will need the signaling. The issue we have, and we've tripped on it in many other drafts, is there's no way to get the signaling to work if you need it during the handshake. So it's actually two classes of connections. We're solving the problem for one class, but not the other.
Since we are short on time, there's this question of, we have TCP EDO. So the question here, the working group chairs would like to get an opinion of is if the working group is interested in working on this document in addition to EDO. So this is right now not a question about making a choice, but whether you think this should be taken up by the working group. Okay.
Okay, thanks a lot.
Thanks for the feedback. Thanks for the presentation. We have one last presentation. And Wes is coming up while I'm clicking as fast as I can.
I can be crazy fast to make time. Because we're not asking for anything at all, other than to see if there's interest. There is another working group in this area called SCONE. It was formed to solve some problems for Quick, but the same problems are also shared by TCP applications that do adaptive bitrate video. Things that do rate limiting within the network cause challenges for these applications. And in the Quick solution that the SCONE working group is defining, there is a way to encode a rate signal that a network element in the middle of the network path can set within packets. That provides advice to the application in order for it to prune video manifests and use that information to select only videos that would fit within the configured rate limits within the network. It's very similar to how MSS clamping already works in TCP. And so we thought it may be viable to define a similar option in TCP as what we have going on in the SCONE working group for Quick. And it would look a lot like the MSS option. It's just that it would be set with a encoded bit of throughput guidance within the network rather than getting set with a MSS value. So that's it. We were curious if other people would be interested in this, especially if you have ABR streaming video applications or something that could similarly benefit from the rate guidance. So I would be curious if people are interested or not.
Any questions or comments? Yoshi.
I just read the draft, and then one thing, I basically like SCONE's idea, but one thing I would like to clarifies, this draft allows to generate middle box acts, right? And that's, I'd like to understand what's the use case for that one. Why we need to middle box generate acknowledgement to include the SCON option.
Yeah, I think that the ability for the middle box to generate this stuff is not something we want to base like it doesn't matter. We could take that out of the draft. We were just putting it in there as an idea. But the SCON protocol for QUIC doesn't actually have that kind of capability for the network to generate the signal itself. So we don't necessarily need that in TCP, if that helps.
Thank you.
Brian?
Hi, Brian Trammell, SCON Working Group Chair. This is really interesting, really intriguing work. I think we should, continue discussing it here. One thing that I would caution about is that like the SCON Working Group has a very specific sort of like set of things that you can signal based on the fact that you get 6 bits in the way that they're doing the signaling. We want to make sure that we are tracking in anything in TCP a very simple and easy to understand how to implement mapping between the SCON code points and the TCP code points, right? In TCP, you have a little bit more like room, so you don't necessarily have to do this trick with the 2 different scaled logarithmic things, but you want it so that like whoever's doing a SCON network element that can write QUIC and TCP is not going to have completely different sort of number spaces for these things, because that just seems like a really good way to like screw up.
Thank you. Thank you, Wes, for the presentation. This concludes the TCPM meeting. See you at the next IETF. Thank you.